When two lines intersect in geometry, they form four angles. Vertical angles are angles opposite each other. Any two intersecting lines form two pairs of vertical angles like you see here. A quick look at this drawing brings up several questions. Are vertical angles congruent? Are vertical angles adjacent? Are vertical angles supplementary? Are vertical angles complementary? Let's tackle these one at a time. Take two straight objects like pencils and place them so that they cross. Now, look at the angles they form. If you study any pair of these opposite angles, you will see that they share a common point at their vertices, their corners. That makes them vertical angles. You will also notice that large or small, they seem to be mirror images of each other. That's because they are. They are the same angle reflected across the vertex. Vertical angles theorem states that vertical angles, angles that are opposite each other and formed by two intersecting lines, are congruent. So when someone asks, are vertical angles congruent, you already know the answer is yes. According to vertical angles theorem, no matter how the pencils cross or how you draw two intersecting lines, vertical angles will always be congruent. How about the question, are vertical angles adjacent? Vertical angles cannot, by definition, be adjacent, next to each other. Another pair of vertical angles interrupts since opposite angles are vertical. Adjacent angles take one angle from one pair of vertical angles and another angle from the other pair of vertical angles. Supplementary angles add to 180 degrees, and only one configuration of intersecting lines will yield supplementary vertical angles, when the intersecting lines are perpendicular. This becomes obvious when you realize the opposite congruent vertical angles, call them A, must solve this simple algebra equation. 2A is equal to 180 degrees. This simplifies to A is equal to 90 degrees. While vertical angles are not always supplementary, adjacent angles are always supplementary. Take any two adjacent angles from the four angles created by two intersecting lines. Those two adjacent angles will always add to 180 degrees. We can see this if we start at the top left and work our way clockwise around the figure. Angle EMI is supplementary to angle IMU and angle EMP. Angle IMU is supplementary to angle PMU and angle EMI. Angle UMP is supplementary to angle IMU and angle EMP. And angle EMP is supplementary to angle EMI and angle UMP. If vertical angles are not always supplementary, are they at least complementary angles? That is, adding to 90 degrees. Again, we can use algebra to support what is evident in the drawings for vertical angles A. 2A is equal to 90 degrees, or A is equal to 45 degrees. Only when vertical angles A are 45 degrees can they be complementary. Therefore, acute vertical angles could be complementary. Complementary angles add to 90 degrees and need not be connected with a common line, vertex, or point. They can be adjacent or vertical in intersecting lines. They could be in two different polygons so long as the sum of their angles is exactly 90 degrees. Complementary angles are each acute angles. In most cases, you can only find the measure of one complementary angle if you know the measure of its complement. If you were told a triangle over here has angle T complementary to angle P in an irregular pentagon over there, you cannot tell anything about the two angles other than they are both acute. If, though, we say angle P in the pentagon measures 57 degrees, then we immediately know angle T in our triangle is 33 degrees because 90 degrees minus 57 degrees equals 33 degrees. Now you know about vertical angles, and you can test what you've learned using the questions and example problems at the bottom of the page.